Hi guys, today what I'd like to talk about is the alternating series remainder. If you look on your formula sheet, it's the second to the last page, and it's just this section right here. So that's what we're going to talk about today. If you look at the very last sheet of your formula sheet, it is this part right here. And this alternating series remainder is not on the 2020 AP exam. So this is for your own edification. So what we know about the alternating series error bound is this, that if a series has terms that alternate, have a limit of 0, and decrease in magnitude, and we know what that means is that the series converges by alternating series test, okay? It converges to some number, so we'll just call that number S. And if the sum S is approximated by an end partial sum, so we know what partial sums are, remember S1, S2, S3, then the error in the approximation, which we call Rn, and that's the same thing as R for remainder. A lot of times I'll call it just error, so the absolute value of R, or the absolute value of the remainder. This is also equal to S minus Sn, so all of these things are the same, will be less than the absolute value of the first omitted or truncated term. Let's look at this series here. What is this series really? Let's go ahead and break it apart. In the first blank, we have n equals 1, so what we'll have there is 1 over 1 factorial, which is 1. In the second blank, we have n equals 2, so when n is 2, we'll have negative 1. Let me change this to a negative sign. Negative 1 over 2 factorial, which is really just 2, so let me change that to 1 over 2. If I have n equals 3, if I put a 3 there, this will be a plus sign, 1 over 3 factorial, which is 6. If I have n equals 4, okay, if I put a 4 there, this will be an odd exponent, so I have negative 1 over 4 factorial, which would be 4 times 3 times 2 times 1, which is 24. And if I have n equals 5, then if I put a 5 there, I'll have plus 1 over 120, and this goes on. All right, so it can go on to infinity, right? And who has time to write all that? So what I say is that if I just use these numbers to approximate, these numbers that I have here, to approximate the value for this summation here, then the part that I don't have here is called my error, right? This part right here is going to be my error, okay? If I call this my sum, so if I say this is the sum of all of these numbers added together, okay, this will be the sum, all right? But I can't really, I don't want to do it to infinity because that would take me all day long. I don't have that much time. So I'll just say if I stop right here, this will be, this number plus my error will be my total sum, or my total S, okay? And this error here has a lot of names. We call it error. We also call it remainder. Okay, and sometimes we call it S, the absolute value of S minus Sn. Okay, and that Sn is however many n's we went here. So here we went 5 n's. So this particular problem would be S minus S5. Okay, absolute value. All right. So this part right here, the numbers here, also has a name, and a lot of times what we call this part, okay, if we add them up, this part we'll call S5, or because there's 1, 2, 3, 4, 5 numbers right here, or we can call it the estimate. Okay, it's the estimate for the total S. Okay, or sometimes we see it as the approximation. Okay, and all these things mean the same thing. All right, so in an alternating series, what we know if this alternating series converges, which it must converge for us to use this error-bound principle, then what we know is that the terms alternate, which they do, plus, negative, plus, negative, plus. They have a limit of 0, which means the numbers are approaching 0, and they also decrease in magnitude. And this picture here is a good picture of what's going on. So what's happening is, as we add more and more and more and more numbers, we get closer and closer and closer to S. Isn't that right? And the fewer numbers we have, the further away we are from S. Okay, so what we're doing is we start at some number A1, right? So here's my A1 right here. So I'll label this. This is called A1. This number in this blank here, and that's 1. So for this problem, my A1 is 1. So I move over by 1, and S1 is going to be 1, because S1, remember, is just the sum of the first term, which is 1. And what is S2? Well, S2 is the sum of the first two numbers, so that's going to be 1 minus 1/2, which in this case will be 0.5. This number is added 1, and I subtract 1/2, so I'm going to subtract 0.5. And what do I get when I subtract 0.5 from 1? I'll get S2, which is 0.5. And then if I get the third sum, this term plus this term plus this term, what that is 1 minus 1/2 plus 1/6. And if you put that in your calculator, you'll get 0.667. So what that means is at 0.5, okay, when I'm at 0.5 here, if I add 1/6, then I'll get 0.667 for S3 here. So I'm bouncing back and forth, right? I'm subtracting 0.5, then I'm add 1/6, and at S3 now I'll have 0.667. And if I subtract A4, so here's A2, A3, A4. If I subtract A4, S4 is going to be 1 minus 1/2 plus 1/6, and now it's going to be minus 1 over 24. And if I put all of that into my calculator, I believe I'll get 0.625. You can check me on that. And so this subtracts 1 over 24, and what I'll get for S4 is 0.625. Okay, and that's what this first, if you're looking at the notes, that's what this first thing says to do. It says approximate the sum of the series by using its first 4 terms. So using its first 4 terms, I'll have S4 is equal to 0.625. All right, the next question says, explain why the estimate found in A differs from the actual value by less than 1 over 100. So let's think about what this alternating series error bound says. It says that if I have a series that converges by alternating series test, so an alternate series that converges, that means these 3 things are true. The terms alternate, have a limit of 0, and decrease in magnitude. Okay, then the furthest that I'll be wrong from my S, the furthest I'll be from my S is the next A term. So let's think about what this means. This means that, let's say I stop at S3, and I say that S3 is an approximate value for S. Okay, well, what is my error going to be? Because S3 didn't add all of these to infinity numbers right here, right? So if I add this with the error, then I'm going to get S. Okay, but what's the most that my error can be? Well, let's take a look at where your S3 is. Here's your S3. How far is it from your S? Well, however far this distance is, okay, it's definitely closer than the next A4, right? So if I add the first 3 terms together, A4 right here actually is bigger than this error here, right? Because what is the error? The error is this value here. Remember, your error is the same thing as your S minus your S3. And that makes sense right here, right? That's what your, right here, that's what your error is. So what I know is my error is no more than A4, okay? And what if I stopped at S4? So let me, instead of stopping at S3, what if I stopped at S4? So I said S4 is 0.625. So let me write what S4 is. So I have 1 minus 1 half plus 1 6 minus 1 over 24. All right, this is my S4. My next term will be plus 1 over 120. This is my A5, right? This is A1, A2, A3, A4, A5, all right? If I say that S4 is my approximation, of course this has a lot of numbers. This is my error, okay? If I say that S4 is an approximation for my S, let's take a look at my S4 right here. How far away from S am I? Well, just this distance right here. But whatever distance it is, it's smaller than this next jump that I'm going to have from S4 to S5, okay? And what is the value of this jump from S4 to S5? Okay, this value here is going to be adding the A5, all right? So what that tells me is A5 is the largest error, okay, that I would have between S and S4. So if I stopped at S4, that's the largest error. My error is going to be definitely smaller than A5, okay? And that's a pretty cool principle. If the problem says, explain why the estimate found in A differs from the actual value by less than 1 over 100, this is what I would write for the answer. I would write, since the terms, first I have to say that this condition applies here. The series converges by alternating series test. So since the terms 1 alternate, 2 have a limit of 0, and 3 decrease in magnitude, and they certainly do. I should definitely check to make sure they do, but they definitely satisfy that. Then what I can say is that my error, okay, and there are lots of ways to write this error. I write it like this, but some people write it like the remainder, okay. Some people write S minus S4, okay, is going to be less than or equal to the absolute value of your next term. So this is my S4, the absolute value of my next term. Okay, so this is going to be 1 over 120. Okay, and that is less than 1 over 100. So therefore my error is smaller than 1 over 100. Okay, and I can check that, but if the denominator is bigger, right, then this number is smaller. The next question says, use your results to explain why S is not equal to 0.7. Well, remember, the biggest error that I have is 1 over 120 if I stop at S4. So that means, S is between, okay, S is between S4 plus 1 over 120 or S4 minus 1 over 120. Okay, because 1 over 120 is the largest error that I could have. So I could calculate this. This means that S is between, I know that S4, right here, this S4 is 0.625, right? So I would say 0.625 minus 1 over 120. If I put that in the calculator, I'll get 0.00833, and S4 here is going to be 0.625 plus 0.00833. All right, so what I have is, let me check the 1 over 120. 1 divided by 120. Okay, that's 0.00833. And so what I want to do is add that with 0.625. Okay, and I'll get 0.633. Subtract it from 0.625, so 0.625 minus 1 over 120. That's going to be my lower bound, so that's 0.617. So what I get is that S is between 0.617 and 0.633, and therefore that's why S is not equal to 0.7. All right. Let's look at another way that they could ask the question. How many terms are needed to approximate the sum of this series so that the estimate differs from the actual sum by less than 1 over 1,000, and justify your answer? So let's look at this problem. Remember, what they're saying here is they want the error, okay, this error, to be less than 1 over 1,000, okay? And if we have this sum, let me go ahead and write this sum. This sum, negative 1 n plus 1 over n4 from n equals 1 to infinity, is going to be equal to, let me put 1 in the blank, that's going to be 1. Let me put, this is n equals 1. Let me put n equals 2 here. That's going to be negative 1 over 2 raised to the 4th power. Let me put n equals 3 here. I'll get plus 1 over 3/4. N equals 4 is going to give me negative 1, 4, 4. N equals 5 is going to give me plus 1 over 5 fourths. And I can go on for a long time. Now the question is, where can I draw the line, okay, so that my error will be less than 1 over 1,000, which means which one of these numbers is less than 1 over 1,000? Well, let's look. This right here is equal to 1 minus 2 raised to the 4th power is 16. 3 raised to the 4th power is 81. 4 raised to the 4th power is, okay, 5 raised to the 4th power is going to be 25 times 25, so that's 625, okay. 6 raised to the 4th power, so 6 raised to the 4th power would be 36 squared, which would be 1296. And what I want to do is choose the number that's less than 1 over 1,000. So remember, to be less than 1 over 1,000, I need a denominator that's greater than 1 over 1,000. All right, and here it is right here. So what I do is I truncate this right here. I draw a line right here between where this is going to be my error. This is going to be my biggest error, okay, my error bound, if I choose these numbers here as my estimate. So this will be S1, 2, 3, 4, 5. This will be S5, okay, plus some error, okay, will be equal to my real sum, okay, and this right here is my real sum. All right, and so what this is saying is that my remainder, okay, I call my remainder error, but you can put remainder if you want. My error is less than or equal to the absolute value of the next term. So if I stop at S5, then my error is less than or equal to the absolute value of 1 over 1296, which is less than 1 over 1,000, okay? And this is only true, I need to write this down, this is only true if the terms, one, alternate, the terms have a limit of 0, and the terms decrease in magnitude. And I should make sure that that happens before I even use this error bound formula. So do my terms alternate? Yes, they do, because of this negative 1 into the plus 1. Do my terms have a limit of 0? Yes, they're getting smaller and smaller and smaller and smaller. Do my terms decrease in magnitude? Yes, if I took the absolute value of these numbers, they are getting smaller and smaller. So my answer is, let's see, how many terms are needed? The number of terms that are needed would be 5 terms. 1, 2, 3, 4, 5.